day, folks. Welcome to my YouTube channel. If you are new here, welcome. Don't forget to subscribe and like all my videos and share with your friends and families. The returning subscribers, thank you so much. Welcome back. I'll continue doing the right thing. Like my videos, watch my videos till the end. Don't skip the ads. That's very important. Now it says a photocell consists of a metal plate P and a smaller electrode E placed inside an evacuated glass tube. The code for a photocell. This is a photocell, guys, right? This photocell, it consists of a glass tube. There's a metal here. It's called metal P. We're not told what metal is that. And then there's an electrode here, which is the receiver, which is when the light is incidented here, there are electrons that are ejected here. Those electrons, they enter that. And then once they enter that, there will be flow of those electrons, and then there will be an ammeter reading there. Right now it says here, guys, when the photocell is in the dark, the ammeter reads 0. When it's in the dark, which means there's no light, right? No light shown there, so there will be no current there. But it says, but the monochromatic red light with a frequency of that. So this monochromatic light, monochromatic light, guys, mono means one. It's a light that consists of a single slit, not slit, a single light like this. It's a monochromatic. Now it says but when a monochromatic light with a frequency of 4.65 times 10 to the power 14 from a 50 watts bulb is shown on the photocell. The 50 watts bulb, it's the brightness. It is the brightness. The brightness, guys, is the what? Is the power as well, or is the light intensity. Light intensity, right? A small current is registered on an ammeter. When it is a light that is 60 watts now, when this light is 60 watts now, which is the 50 watts, it's there will be a current there. All right, now it says the table below shows the work function of the two metal, which is the cesium and gold. So here are the metals, right? The metal, it's cesium and gold, and their work function. The work function of cesium is that one, and the work function of gold. So between the two, which one ejects the electron easily is the one with the lowest work function. Now it says in 10.1, determine by calculation which metal, cesium or gold, should be chosen to make metal P to ensure that the photocell works with the red light. Explain your choice clearly. So this, we're going to do it by calculation. So 10.1, what are we going to do specifically? We're going to calculate the energy of this monochromatic light, and then we compare with these work function. So if the work function, if the energy of the light is greater than these work function, that means that is the suitable one. Okay, let's calculate the energy of the light. All right, the energy of the light is HF, right, which is the H at 6.63 times 10 to the power negative 34 times the F. The frequency of the light is 4.65. It's 4.65 times 10 to the power times 10 to the power to the power 14, and then the answer there, it will be, when you punch it, 3.08 times 10 to the power negative 19 joules. And then what do we do now? We compare this energy of a light and the threshold frequency. So this energy, how is it with the cesium? If you look at the cesium, it is greater than the cesium. So if the energy is greater than the work function of the cesium, therefore the cesium, this is for cesium, this is for cesium. Therefore, this means cesium is what is chosen. This is the one that is going to be chosen. Why? Because the energy of this light, do you see, it's bigger than the one of cesium. This one for cesium, it's 3, and this one is 3.08 times 10 to the power 19 times 10 to the power 19 there. But if you look at the energy, how is it compared to this one of gold? So the energy of the light is lesser than the work function for what? For gold. So the gold is not chosen, right? I hope I make sense by that. Now it says the 50-watt bulb is replaced with another bulb with the higher intensity. So they use the 50-watt bulb there. Now they've used the one with the higher intensity. Let's say they use the what? The 60-watt bulb, which is the more brighter bulb now. Now it says, what will this have what effect will this have on the ammeter reading? Give reason for your answer. Very important. In 10.2 guys, let me write the answer here. 10 point, it's an explanation. Guys, when you increase the brightness, there will be more or higher current reading in the ammeter. Guys, when you increase the brightness, there will be the reading here, it will read more if you increase the brightness of the light, right? What is the reason for that? That's 1 mark. Remember, it's 2 marks. Now guys, what do you need to remember? Each photon in the light in the light ejects one electron. So more photo the more photo electrons ejected per second. There will be more photoelectrons ejected per second there, guys, if the brightness increases. Okay, we're done with that. 10.3, light with this frequency now falls on metal P, and P is made cesium. So the metal P is cesium, and this light has this frequency now, and we know the work function of cesium is that one, right? Now the question, it says calculate the speed of the electron emitted. So 10.3.1, calculating the speed there. We know the speed, we're getting it from the kinetic energy. So we'll use the formula that says the energy of the light is equal to the work function plus the kinetic energy maximum. So what we want the speed. We'll get it there. So the energy, we'll use the H. What are we given there? We're given the frequency, so we'll use the HF. And the work function, we do have the work function, and the kinetic energy, we'll say half mv square. So what do we want? What do we have? Do we have the Planck's constant? We have the frequency. We have the work function of the cesium. We have the mass. We are looking for the speed there. So the Planck's constant is going to be 6.63 times 10 to the power negative 34 times the frequency. The frequency here, it's 121 times 10 to the power 121 times 10 to the power positive 15. And the work function for cesium is 3 to the power 19. That's 3 times 10 to the power 19. Is it positive or negative? It's negative 19. Plus, and then we are here now, it's going to be half the mass of the electron. You get it from the data sheet. It's going to be 1.11 times 10 to the power negative 31. And then the velocity square is the one that we're looking for. Guys, mathematically, you take this to this side, right? So it's going to be, basically, it's going to be 6.63 times 10 to the power negative 34 times 1,121 times 10 to the power 15. And then this answer here, you minus this, you take that to that side, it's going to be 3 times 10 to the power negative 19 equal to that. So it's going to be half 9,11 times 10 to the power negative 31. And then we have a v squared. So we'll divide both answer by half. 9.11 times 10 to the power negative 1. That's a negative 31. And then we divide by half. 9.11 times 10 to the power negative 31. Alright. And then this and this will cancel. So we'll have this as an answer. So you'll say V is equal to this. So your answer there, it's gonna be 1,05 times 10 to the power, when you put that in the square root, meter per second. This is the speed of the electrons that are emitted or ejected on metal P. That's 10.3.1. Now the 10.3.2, it says, does the work function of cesium increase or decrease or remain the same when different frequency of light? Guys, and whatever that you change in the light, whatever that you do, you increase the brightness, you change the frequency, you change the energy, you change the wavelength, whatever that you change in the light, it won't affect the work function. And the work function of the light does not change. So the answer here, it will be remain the same. All right, let's leave it like that. That's the end of the question. I hope it makes sense, guys. Cheers, bye.